What's good, YouTube? If you're watching this video, you successfully made it to layer 7 of that Orside model, where we give you nothing but that application you can apply directly to your life. Welcome to another episode of Cloud Networking on AWS. I am your host, Dwayne Lightfoot. And in this episode, we will be discussing a topic that many of you have contacted me and asked me about. And that is, how will generative AI affect you, the network engineer? I have my opinions on it, but my opinions are just opinions. I wanted to bring someone into the studio to have a conversation and answer these questions that really understands generative AI and machine learning. Today, I want to introduce you to former AWS hero, now turned developer advocate, Mike Chambers.
Duan, hello. How are you? Thank you so much for the invite to be on your show. Really appreciate it.
No, thank you for coming on.
No worries at all. Look, I'm really excited to talk about generative AI. So I think there's a lot of opportunities for people. So let's look at it from a positive framework and let's talk about it.
I didn't want to start it off as, is this the end? I begin that question a lot. So, Mike, I wanted to ask you to kind of frame the whole conversation. What is generative AI?
Okay, yes. And that's exactly the right place to start, right? So generative AI it's a type of machine learning.
Okay.
And it's a type of machine learning that looks to generate content. I guess that's in the name, right? Generative AI. And it's looking to make content which is like a human would be able to create. So whether it's like text, as we've seen from chatbots, or whether it's images, like we've seen from some of those websites you go to and you type in the description of an image that you want to see and it generates some amazing image. So that's generative AI.
You make it sound so simple, but it's really changing the industry.
Yeah.
How is it doing that?
Well, that's a big question. And I don't think we know the full answer to that yet, right? So primarily right now, large language models are the main tool. So if you're using a chatbot, if you're using ChatGPT, then those applications and chatbot applications under the hood are using large language models.
Right.
Those models are the things which are really driving most of the value right now. So images are great, but those large language models are really the things that we're using. And I think we can see some of the use cases for those that are emerging, but it's up to different people in different industries to try and figure out how they're going to get used and how it's going to take us forward. I think a primary thing at the moment, a really good example of it would be for application developers right now using generative AI to help them develop code, to be much more efficient at writing code. So using plugins inside of their IDEs and development environments to write code. That's a really good example of something where generative AI, it's more than just a toy. It's not just writing poems and writing songs in the style of your favorite artist or whatever.
Right.
You're actually using it to make real progress. So I think that's some of the exciting stuff that's happening.
It's a lot. When I talk to network engineers, I've seen people be able to take, let's say, for example, a prompt and put it into a chatbot or some other type of generative AI tool like ChatGPT, and it gives them code that they can then apply to their network or do something on their infrastructure. What are your thoughts? Is that a good use case? Is that where we're headed right now?
Well, I think using generative AI to write code, as developers are right now, I can absolutely see that as being a use case moving forward. So yes, I think what's really important, I think what conversations like this can bring out as well, really help, is to make sure that people really understand what generative AI actually is.
Right.
Because, you could go to a search engine and you could type into a search engine, how do I perform a certain operation on a network switch, for example? You'd probably go to Stack Overflow, you'd find an answer, you'd copy and paste it. So the workflow is kind of the same,
right?
But where the data comes from compared with when you're going to a large language model powered application may be quite different. And so it's important for people to sort of understand, peel the lid back just a little bit and understand how large language models actually work.
Yes, and you have done a lot of work lately to kind of help others understand this.
Right, absolutely. So I'm not going to say that I was involved with putting together the architecture for large language models. Far smarter people than me were involved in doing that. But yes, we've done a lot of work recently to sort of peel apart and to sort of look under the hood how it works and to help explain that to anybody who wants to know, which I honestly think should be pretty much everybody. So I think that's important. So when you look at a large language model, what it's doing under the hood is that it's a machine learning model, as I said. Now, with machine learning models, they are algorithms, lots of code, lots of intricate code that can learn about data that we throw at it. So really simple version of this would be, well, it's simple by today's standards, but it was fairly complex at the time, is where we do image classification. So we might be able to have a whole bunch of images of dogs and a whole bunch of images of cats. It's the dogs and cats thing. It's what we always talk about. And we can say, here are all the pictures of dogs, here are all the pictures of cats. And you provide that to the machine learning algorithm, and it churns through all of that data and cycles through that data, learning what dogs and cats and what the characteristics from a statistical point of view looks like. And so then the output from that is a model. And that machine learning model can then be used to classify images, in this case of a dog or a cat. So that's machine learning sort of 101 in a nutshell. That's what machine learning does. It takes large amounts of data, trains models to be able to do these tasks for us. Now with generative AI, essentially it's the same. But what we've done is we've taken all of the information that we can find from the internet, usually, because we're talking text stuff here, right? So we're thinking about, everything that's on Wikipedia, the complete works of Shakespeare, everything that's on Stack Overflow and GitHub and all the rest of it, and putting that into a learning process so that the model can learn what language looks like. And that's kind of what it's doing. It's just learning the patterns of language, things that maybe linguists understand, maybe things that we don't understand, just the way that words flow together. And so that model then has all of that information inside it. And we then said, you said before about the prompt. You type this prompt in and it gets the model to do something. What the model's actually doing is it takes that prompt, it looks at the words in that prompt, and it figures out, statistically speaking, using the algorithm that it's trained for itself, what's the next word going to be? And that's all it does. And this is why it's so incredible that these generative AI tools, honestly, that they work at all, and that they come out with such good quality output often, not always, is because all they're doing is just predicting what the next word's going to be. Now, you're going to say to me, well, I've seen, in interactions with chatbots that they produce more than just one word. What happens is that they produce one word, then they send all of that prompt plus that one word back into the model and predict the next word. You'll have seen, like, when chatbots generate one word at a time, they're not doing that for some kind of web effect. It's actually figuring out one word at a time. And so it's just a statistical calculator, an incredibly complex and sophisticated calculator, but it's just that, predicting what the next word's going to be over and over and over again. So it's not going to an authoritative, what's the word I'm looking for? Authoritative document, and saying, how do I perform this action on the Cisco switch, whatever it is. It's saying, out of all the language that I've seen before, what would the next words look like? And if it's generating code, it's because it's looked at code and it's saying, well, this is what I imagine I would see next. So it's incredible in a way that you can then take that and execute that code, and that it actually works in many cases, not always. So it's coming from a very different place. And I think it's super, super exciting. I do think it's super exciting, genuinely, and amazing that it works at all.
I've heard so many people that are in data science, that are in machine learning, that are still fascinated that this actually works. So that lets me know that it's kind of complex behind the scenes and is learning in ways that wasn't predicted in the beginning.
Well, that's right. Yeah. So it's the emergent properties is what we're calling it. Basically, emergent properties is another way of saying, wow, I wasn't expecting to see that. So yes, I mean, machine learning models have been trained for a long time, and often when you sort of start the project, you can kind of, what you're trying to achieve. Right. And so what's happened with generative models, I'm loosely speaking, relatively small models were created that did okay at sort of predicting what the next words were going to be.
Right.
And being a sort of a simulation of language, right? So you'd get some pretty crazy stuff in the early days. Right. But then over time, these models started to get bigger. So we measure model size often by parameter size. You'll hear sometimes people talking about like a 7 billion parameter model, 40 billion parameter model. That's pretty small by some of today's standards. So 100, 200 billion parameters is not unusual these days.
Cool.
And those models are not only understanding language, but it appears that through their understanding of language, they actually have sort of grasped other concepts, such as developing code or writing a poem or whatever it happens to be. So, or reasoning and being able to sort of think their way through tasks. I just need to say, they're not sentient, they're not alive. We'll just cover this right now. That's not a thing.
I understand.
But they exhibit behavior that almost makes you believe that they are. And so I can understand why people might say.
So it seems that they may be exhibiting behavior that they're network engineers.
Right, sure. Absolutely, why not?
So the next question I have is, how does generative AI apply to network engineering?
Well, that's a conversation we need to have.
Yeah.
And I think that's a conversation that lots of different skill sets and job sets need to have.
Right.
So we have these tools available to us that just weren't available to us like a year ago. The capabilities that we have readily accessible to now just weren't a thing. So what can we do with them? That's a kind of open question. I think that there are some industries, like I said, with developers who are sort of getting a little bit more familiar with what they can do with it.
Right.
And I think that once someone who's very skilled in a particular job area, such as networking, if they can understand what the model can actually provide for them, then they can marry those two things together and we can see what can happen next. One of the things about large language models is about where the data comes from.
Yeah, that was
right. So we've talked a little bit there about the initial foundation model is what we call it. So the base model, a foundation model, the initial thing that's created. It's probably worth just pointing out that these things are made by development teams who are performing really big computational jobs to be able to create these models. Right. It takes months. It takes potentially millions of dollars to train foundation models. So we don't typically do that ourselves. I'm not going to go home on the weekend and say, well, what shall I do? It's raining outside. I know I'll create myself a foundation model.
Right.
That's not going to happen. So we take a foundation model that someone else has made. So the foundation model's got a great sense of language. Often it can sometimes follow some instructions depending on how it's being trained. And it's been trained on, as I said before, all the data that they can sort of scrape together or that they choose that they want to use to train it. So it's quite often quite generic in nature, and it's going to give them this understanding of language. So if you take one of those foundation models and you ask it a question or you prompt it in order to be able to get it to produce some output like how to configure a network or whatever it might be, then if it produces an output, it's based on that stuff that it's done in the past. It's based on that stuff that it's read in the past. And it may or may not be relevant to what you want to know. It might be an older version of a software stack or something that you're looking at, because there is a point in time which you stop training that foundation model. It now no longer knows anything beyond that point. So that's something to bear in mind, right? It doesn't know what your network looks like right now,
which drives another question, and it's a term I heard. Hallucination.
Okay. Yeah.
If it doesn't know what the network looks like, if it's never seen documentation on that particular device or architecture,
yes,
it will just create something out of thin air, from what I hear hallucination is.
It may well do that. And so it's predicting the next token of what it thinks, or next word.
Right.
And it's doing this iterative process of predicting the next word to see what sounds reasonable. So instead of saying, I just don't know, it'll say, well, these words sound reasonable. Like to move it out of a technical realm, something that a lot of people do is they type in their name into a large language model, say, who is this person?
Right.
Now, aside from people who are very well known in the public space, who there is lots of information about on the internet, it will likely just make up a story about somebody with that name, because it's just predicting words that sound reasonable and that would sort of pass the sniff test, like a human might write that. It's not factual. It's not trying. It has no. It never claims it is going to be. So yes, hallucinations are a thing. They are, however, really. I don't like calling them hallucinations. Really, it sort of implies that. It almost implies like it's alive and it may be trying to dream.
Right.
Like, robots don't dream. Robots don't dream of electric sheep. It's not a thing. It's an algorithm that's just producing words. And if it gets the wrong output, it gets the wrong output. Back in the day, I'll move back again for original machine learning, or other types of machine learning. We didn't call it hallucination. We just called it poor accuracy. And that's what it is.
Right.
So if we had a classifier that was going, that's a dog, that's a cat, that's a dog, when it's actually a cat, we go, well, it's actually, we're not as good on the accuracy score as we'd like to be. So really that's what it is. So it's an accuracy issue. The issue is it's sort of wrapped up in language and we get emotional about it and we call it hallucination. And I'm okay with that. But it's important to realize what it is. It's not being malicious. It's not trying to drive us in the wrong direction. It's just a statistical engine which knows no better. I suppose there are a couple of other places we can get data from, though. So the initial training is great. It gives us the ability to be able to work with language.
Right.
Fantastic. What about if we want it to deal with data which is more specific to us in the here and now? There are some ways that we can get our data in, and one of the ways is with prompt engineering.
Okay. Let me hear more about that.
Yeah, so prompt engineering is definitely a skill that I would encourage anybody watching this to read up about and to understand, because it sounds much more complicated than it really is, but it's often the way that we get most of the power out of a large language model. So prompt engineering, really all it is, it's string manipulation. So if you can write a Python code or simple code to add strings together, then you're doing prompt engineering. And basically, it's how can I structure the prompt in such a way that I'm going to get the right answer, more likely to get the right answer out of the large language model. And in the case of something like, say, configuring a switch or doing some sort of networking administration, what you might do, and we need to talk more about this, but what you might do is take the output from the switch. As you go to the console, you'd dump the configuration of the switch out, for example, and you put that into the prompt. And you might say, tell me something about this. I don't know what you might want to know. Which ports are currently, out of action or whatever it is. Yes, exactly. Yeah. And then upload a bunch of textual information that the answer is in there, but maybe it's just too big for you to scan through. And you can pass that into the large language model. And there is every chance that it might go through that with your prompt at the end with that specific question, like which port's down. Now, what's it going to do? All it's going to do is it's going to look at all of that and it's going to say, okay, well, here's the context of language that I have. I'm going to predict the next token. And with a large language model, the token predictions, the word predictions will be the answer to the question. And it's using the context you've added in. It's called in-context learning in the generative AI space. And it's a way to be able to get your live data into the language model for inference right now, for a prediction or generating a response right now.
So you're passing the data up front, and you're telling it from the information that I've supplied, what is this answer?
Exactly that.
Okay.
Right.
Okay. That sounds pretty powerful, but you mentioned something when you're getting the response back from the tool. How do you validate it? How do you determine if that answer is not a hallucination or something else?
That's a real challenge. You as a domain expert might have to look at it and say whether it's right or not.
Right.
It's not something which has a clear-cut answer, really. So, yeah, I'm going to say that's probably a bit of an open question. I think what we can do is we can perform testing and we can put it through lots of different scenarios where it's looking at these outputs and configurations.
Right.
And we can get a decent sense that it's going to get things right.
Right.
But there isn't really a way to guarantee that the output is correct all the time.
So we're thinking like of a workflow, let's say a CI/CD pipeline, and you're passing data into the chatbot. The chatbot returns a response. It's in the pipeline. You have some type of validation built in. Let's say it returns configuration back, and you take that configuration and unit test it or validation test it. Have you seen anything like that be done in the industry?
It certainly could be done, right? It certainly could be done. I think that would be a good idea. I'm gonna say there is one rule of machine learning, which is probably a good idea to wheel out at this point, and that's don't use machine learning unless you absolutely need to. So, do you mean? I mean, we gave that example of, is a port down in this configuration file. That's probably fairly easy to script, I would imagine. In fact, you can probably send a command in and just get the answer straight out, right? So maybe just in my eagerness to come up with an example and make it sound like I know what I'm talking about when I'm talking about networking configuration, go with that example. But maybe it's not a good one. And so you're really looking for large language models to perform more complex operations where, a human would usually be involved. So I don't know necessarily how that might translate.
Like telemetry, heuristics of your network to determine patterns in your network. Would that be a good example?
Right, yeah, maybe, yeah. I mean, anything where you could actually determine it by reading the whole thing,
right,
and then also knowing a bunch of stuff,
right.
And then that works, and you could bring those two things together.
Okay.
Definitely, if you're looking for it to output commands of code and all that kind of stuff, then that makes sense. So going from natural language to a structured statement. For example, like I've played around with large language models that work with the AWS command line. So I can type in, show me all of the IAM users that don't have multi-factor authentication on. And of course, when I run that on my account, it doesn't have any because I have multi-factor authentication on all my accounts.
Right.
But in the real world, it comes back with a list of, so it outputs the command line of what you need to put into the command line to get that to come back, right? So that kind of language translation, right? You're translating natural language into a technical language. That's a pretty good use case for generative AI.
So this gives me another question that I have for you. You're asking it to return all of your unauthenticated accounts.
Yeah.
Your unauthenticated accounts returns. Now, the next step would be say, okay, go apply multi-factor authentication to these accounts.
Well, for sure.
Should you give it access to your network or your infrastructure?
Well, yeah. Well, yes. That's up to you, right? So let's check in with that. So first of all, I'm asking the large language model to come up with the command.
Yes.
It itself, in a vanilla initial setup, doesn't have an ability to be able to run that command. Right. It's just coming up with language.
Exactly.
Because remember, all it's doing is next word completion.
Right.
What we can do, and what people are doing, is wrapping up a large language model into an application which includes agents or connections into the outside world. Right. So it's actually an application that you write, which sits in the middle, or configure, and it sits in the middle. It has the ability to tap into a large language model to do the understanding of natural language. And it has the ability to tap into other systems, such as running a command line or grabbing something from a database or hitting an API. And what you can do is you can tell the large language model, and this is another thing that absolutely blows me away. And this is the new way to develop code, essentially, is to tell the large language model what it can do in natural language. So you might say to the large language model, you're a large language model. They literally say this. You're a large language model. You don't have the ability to answer questions about my networking infrastructure, but you have access to these agents, and these agents do various jobs. Agent number one is issuing a command line interface on this switch. Right. Tool number two might be accessing an API and getting some data back, and describing what is on the other end of that tool, so that the large language model can then create commands for that infrastructure, pass it back to the orchestration piece in the middle that we're writing. It then performs the action because it's a piece of code, and so it's performing the action on the switch or whatever it is. It could then grab the information back, give it to the large language model, and sort of complete and keep the cycle going. So there are opportunities to do things like that.
So it's a series of API calls, basically, where these agents have access to your network, but the actual tool does not.
The large language model does not. That's right.
Okay.
And the tool just uses the capability of the large language model to translate your commands, if you like, the natural language commands, into something which can actually, which can perform some actual tasks. So
that makes sense. So you don't necessarily have to give it access to your network. You can centralize the access to your network and have an API call between that worker and the tool, and then the worker or another worker has access to your infrastructure.
Yes.
Okay.
But I said yes. So the thing is that so at some point the large language model is generating, say for example, the code.
Right.
Is there going to be any sanity check? Is there going to be any linting or anything of that before you actually run it?
Right.
Now, if it was me, I think certainly initially I would be running it in read-only mode. And so, tell me about stuff. Don't actually do stuff.
Right.
I mean, how can we be sure that it's not going to send a command to just, delete a whole bunch of network configurations? We can be somewhat sure because we can test things and we can template things out. I just said you can't be completely sure at this stage, so you just need to be careful and go slowly. Let's build up to this. Let's not run before we can walk. The other part to it, though, is we kind of glossed over this. I think I might have pulled a face as I mentioned it. But we're sending our network configuration in this case.
That was the
right. Okay,
yes.
We're sending our network configuration to a large language model.
Right.
And so from an information security point of view, from a compliance point of view, for all kinds of reasons, just in the same way as you probably wouldn't take your network configuration and post it to social media, you need to also be careful about where you're sending your data. So you need to make sure that large language model is in a trusted environment. You need to make sure from a compliance point of view, you're even allowed to send your network information there. Do you want to do that? What's the security controls around it once you send it there? All of these types of things. Right. So sometimes, I mentioned before that orchestration software and software stacks that you can use, they kind of abstract you away from some of the detail.
Right.
And so sometimes you don't really kind of think about it. But it's important to remember, this is why I was saying at the top of the show, to think about the way that large language models work. All they do is that next token prediction from the prompt. There's nothing more special than that, even though it's amazing.
Right.
So we do have to send our information there, and we just have to be thinking about that information security thing, because I think that's obviously really important. So yeah.
So if you send a prompt and it has your network information and you're telling it to learn from that data, does that data go into the large language model, or does it sit in that one prompt? Let's say API call for
sure.
Work.
So at a base technology level, so if we're talking about how these models work, then no, it doesn't go into the model. So you're using that just as the prompt, just as extra information in the prompt.
Okay.
And it's a very point in time thing.
Okay.
It's up to the to whoever is implementing the interface to the large language model, whether they want to capture that and figure out if they can figure out whether you thought that was a good completion or not, or output generation, and decides to update their service. So that's a thing it could do. But at the base technology level, it wouldn't. If you want it, I mean, there are, of course, you can fine tune these models, and you can create if you wanted to create a model that understood everything about your infrastructure, then as long as you've got your own data set, then you could do some more expensive training and you could build your own personalized model. But that's probably not necessary right out of the box, and prompt engineering is good. And yeah, that data that you send, it doesn't go into the model by default.
Okay.
But it's up to whoever's operating the model.
Now, something you mentioned about prompts, and is something that I've heard, and I wasn't really clear on tokens.
Right.
What is that?
I probably interchanged words and tokens, and it's like a force of habit. Sorry.
Okay.
Let's talk about this. So when you have your prompt, so it's natural language that you're sending in, machine learning models don't deal with words. They have no idea how to deal with them, and they haven't forever. They can only deal with numbers and maths. So we basically have to convert the words of our prompt into numbers, and those numbers are tokens. Now, there's a couple of different ways to do that. You can send, for each word can turn into a number, or each part of a word can turn into a number. So a token may be the whole word or a part of a word. And it's the same for every time you use that particular word. So if you put in the, then it might give you the number 149, and then the is always represented by 149. So you can convert all of your text into numbers. send it into the model. It can do all of its stuff. It'll predict new tokens, which are numbers. And on the output, before we finally see it, it will detokenize it and turn it back into natural language. So that's what tokens are.
Yeah. So every time I thought it was getting simpler to understand, you just made it even more complicated.
Oh, I'm sorry. Yeah.
No, it's not. I mean, because essentially computers is 1 to 0.
Well, that's right. That's right. Yes. And inside of a large language model, like, I'm not even going to go there because you think that was complicated. It's really quite complicated, but it's just doing math, lots and lots and lots and lots of math. Right. So all those billions of parameters are basically individual calculations. Every single time you have a new word coming out, there is like several, maybe 150 to 200 billion calculations for every word. So it makes you think. I mean, make sure that you use it responsibly.
So for let's say a network engineer really wants to understand machine learning and prompt engineer, will there ever be a point where they have to understand the math behind it?
I don't think so. No, there's no, okay. You won't have to, no. So there's, machine learning engineers and AWS have got services, for example, which expose really quite sophisticated machine learning algorithms to the outside world that you can connect to through an API. So we've had things like recognition for image classification, comprehend and transcribe, and all these services, which have, they've got some pretty heavy lifting code in the background,
right,
but you can just interact with them with an API. So more and more, I think we're going to find that we are integrating with even things like generative AI through an API, and Bedrock's coming, right? So Amazon Bedrock's coming.
Yes.
Everybody's talking about it.
Yes.
And that's an API endpoint that you can use to generate, to perform generative AI, large language model.
So the large language models, do they get smarter, larger?
That's an interesting question. Okay. So we talked before about how they're getting bigger and bigger and bigger,
right,
and they're getting these new emergent properties. What we're also now seeing is that sort of people are going, whoa, hang on a minute, this is getting really big. Like, these are really expensive to run.
Right.
And so we are also seeing much smaller models. So we're seeing things like 40 billion parameter models, so less than half the size, which are showing to be just as capable or almost as capable as some of those really, really big models.
Right.
So we've kind of gone through this explosion period, right, where we're just making these bigger and bigger and bigger. It's getting really, really exciting, but it's getting a little bit maybe too big for some players in the market. So they're sort of coming back to, let's optimize. Let's focus on optimizing for a bit. And so, so at the moment, I think, and things change all the time really, really quickly, I think the top open source model is called Falcon, and it's 40 billion parameters. So it's kind of smaller. It's achievable. You can actually deploy it into your own account if you wanted to.
Oh, wow.
Yeah.
Okay. So the next question I have, when it comes to generative AI in network engineering, I think we kind of talked about the use cases. We talked about what it is. We talked about how it kind of applies to network engineering. The question I have for you, will it eliminate network engineering job roles? I just want to know.
Way to put me on the spot.
Put you on the spot.
Yeah, way to put me on the spot. No, genuinely, I don't think so.
Okay.
What I will say is that I think that for pretty much everybody, generative AI is going to it's going to change everything for everybody. I think this is my personal feeling here.
Right.
And I think that much in the same way as it has for developers, it's just going to allow people to adjust the way they work more efficiently, do more. Certainly, I use generative AI when I'm developing code, and I'm no developer, but I can get stuff done.
Right.
And I'm just generating way more code than I ever have before, and I'm getting way more done than I've ever done before. Yeah. So that's the kind of change I expect to see. So I think people getting into the space will start to use these tools. They'll become really effective.
Right.
It'll unlock things that we just couldn't really achieve before, just because we can now generate. We've got we've got algorithms helping us to accelerate us forward.
So the question answered is it would change things across the board.
I think so.
But I think we kind of talked offline when people that are thinking about the jobs that may be eliminated, it also creates a bunch of jobs as well in different roles to be able to support the large language models, the code behind it, and just the IP that is being presented with it.
Sure. Yeah, look, I mean, things change all the time, right? If you were someone who was looked after horses for horse and carriages a long time ago, then There's a lot less of those now, and now people look after cars instead. I'm looking for other analogies, right?
Yeah,
so continually these things move along and change. And so, you know, we adapt and we grow, and we adapt and we grow. Look, I mean, if you know, we work in cloud, right? So I mean, like people who are working in on-premise data centers, they still exist in the world.
Right.
Honestly, there's probably less of them. So we move into a cloud environment. We start working with cloud infrastructure. I think that's a positive thing. We adapt and grow. We move. I've racked servers in a server room. It was a while ago now. I got gray hairs to show it. And now I work in the cloud, and now I'm working with generative AI. And I think I'll look at it as an opportunity, and I don't care what anybody says. I am super excited by it.
So looking at it as an opportunity, thank you for that. How can someone, network engineer or non-network engineer, get started with generative AI?
Well, my number one tip is to get started. Just look for the opportunities to use any tools you can get your hands on.
Okay.
So at AWS, we have Code Whisperer, which launched a few months ago.
Right.
So Code Whisperer is a completely free plugin that you can put into your coding environment to help you write code more effectively. So it's basically generative AI pair programming. So if you do write Python scripts or JavaScript or whatever it is, you can say, for example, write out the top line of your function that you've defined, and then watch Code Whisperer complete the rest of the function for you. It feels kind of magical. You have to see it to sort of believe it almost.
Yes.
It's not just code completion. It's actually taking the variables you defined, the libraries you've installed, and saying, okay, well, you called this function such and such. There's your code.
Right.
Super exciting. Definitely look at tools like that.
Yes.
In addition to that, we've got these services such as Bedrock coming out. So if you want to start developing an application which makes use of generative AI, certainly have a look at how that works. You can send your prompts in, get your completions out. It's managed environment, so you don't have to deal with all the infrastructure. So similar story to other services we've sort of seen. So that's certainly worth having a look at too. If there's anybody who wants to dive in deeper, and this is quite a lot deeper, I must admit, but if there's anybody who's interested in diving in deeper, apart from reading all of the papers, as I've done, that's some extra grey head, we are actually launching a course. I think by the time this video's out, the course should be launched. So we've worked really, really hard with our friends at deeplearning.ai. And Andrew Ng, who is an amazing superstar in this field.
Yes.
So we spent a whole bunch of time at their place. We put the course together. We worked with Andrew. And maybe we can put a link somewhere next to this video.
Yes, we will.
Down below.
Description. Yes. This video.
If people are interested in that, along with Code Whisperer and the sign-up page for Bedrock too.
Mike, this has been a really in-depth conversation. For those of you that have tuned in today, thank you all, and thank Mike for joining us.
Thank you.
If you have questions, comments, leave them in the comment section below. Like this video, subscribe to our channel. Be on the lookout for more cloud networking on AWS episodes. We thank you all for viewing, and we will see you on the next one. Peace.